Okay, great. I think, yes, we are live. Um, okay, great. I got the confirmation. Thank you. Uh, Thank you so much, everyone who have joined us till now. I think we are on time and let's start. Uh, Hello, everyone. My name is Saurabh and I work at IBM as the Developer Relations Engineer for Open Source Presto project. And I welcome you to our hands-on workshop series. And this is for we have Kiersten Stokes with us. She will be our instructor for today's workshop, and she will be taking uh, I think a deep dive into the today's topic, and she will be explaining in much detail. Before we start uh, our workshop, just do the as usual ritual. Please join our Slack channel, Presto Slack channel, if you haven't joined till now. That's the place that we all our discussions happen, all our announcements, everything. So please, if you haven't joined our Slack channel, the Presto Slack channel, that's important. So please join that. Also, you will find all the links on the official Presto TV website and also the description of this video, right? So if you are watching us on YouTube live, so you will find all the links in the this description of this video. Also, please join the meetup groups. That's very important because we do all some of these hands-on workshops, events in person, virtual across all these cities. Bangalore, Paris, London, New York, San Francisco. So if you are in these cities or if you are around these cities, please join the meetup groups. We post events, and if you want to join those events, please do that. Right? So you will get all the notifications there. So yeah, uh, uh, let's welcome Kiersten Stokes. Thank you so much, Kiersten, for doing this, and welcome to this hands-on workshop. I spending your today's time with us and helping our developers, helping our community in learning Presto in more structure and more detail. Over to you, Kiersten. Thank you.
All right, sounds good. Thank you. Let me get my slides up here. All right. And of course, when I do that, my Zoom window has completely disappeared. So if there's any problems, just interrupt me to let me know. That's probably the easiest way. But yeah, we all probably know what the title of the workshop is. But we're going to take you through a Presto observability pipeline. Shout out to Saurabh because he actually created the content for this workshop. I'm just talking about it today. But it's really comprehensive and I learned a lot going through it myself. Here, let me advance the slide to the introduction. So I've been contributing to Presto for at least 3 years now. It might be 4 at this point. I've kind of lost track. Most recently, I do kind of more of this style of thing, community events, where I'm presenting various topics. But most of my Presto experience is actually with the Iceberg connector. And if not Iceberg, other Lakehouse connectors like Apache Hoodie and Delta Lake. So this topic in particular, as I mentioned, is kind of new to me as well. So we're going to do a little hands-on session. If you don't, if you're intending to follow along for the session, you will need a few tools locally. So Git is one of them, as well as Docker and Docker Compose, or if you use Podman or Rancher, both, any of those will work, but I'll be referring to all of the above as Docker commands. But yeah, happy to be here. I'm kind of going backwards here, but I also work at IBM with Saurabh. I'm an open source software developer. So in addition to Presto, I've also contributed to several other open source projects, specifically those that are strategic to IBM. So LM Evaluation Harness, PyTorch, things like that. But Presto is kind of special. I always like to give Presto a special shout out because as far as the community for Presto goes, it's one of the best of all the projects I've ever worked on. It's pretty rare in my opinion that a community is so welcoming. So definitely join the Slack channel if you're brand new to Presto. You can get your questions answered there. Everyone's very welcoming and easy to talk to. So, and in addition, you're welcome to direct message me in the Presto Slack. My picture's the same everywhere. So, and my name. I'm one of the only Kiersten Stokes out there, I'm pretty sure. So yeah, if you have any questions after the workshop, feel free to message me, and we can continue the conversation. So here's our agenda for today. I am going to start off top with more of just this
Kirsten,
talking at.
sorry
Yes.
to interrupt you. Your screen is
No
not
worries.
visible. Your screen.
Oh, it's not.
If you can share your screen.
Thank you. The heck, I'm getting the green border and everything. Let me stop and try again. There?
Yes, absolutely. Now it's
Okay.
fine.
Strange. All right, let's get back to the slides that I was sharing. You haven't missed much. Nothing interesting has happened yet. Oh, I will show you the picture that I guess that you can look out for in the Slack channel. That's the picture I use for everything. But yes, all right. So as far as the agenda goes, I'm going to talk up top with the slides that I am now sharing appropriately. And we'll essentially just go through all of the different components of this observability pipeline that we're going to set up. Then the second half, probably more than half, kind of depends on how things end up timing out with questions and things like that, will be the actual workshop itself. So we'll do a few things in the workshop. We're going to, trace a single simple query through the entire pipeline. Then we'll do some things like, that are a little more testing of the system and all of the rules that are set up to see how they are looking in our observability dashboard. And finally, we'll test also the alert management system as well. But I do want to stress this workshop in particular it was kind of hard to decide what points I should cover in the actual 90 minutes and what points we just didn't have time for. But you can really take the outline of what's available in the Slack repo that I'll share with you and do a lot with it. So there's a lot more to be explored than we will, officially be covering here. And I do recommend you do so because it's actually a fairly sophisticated demo for what it is, in my opinion, at least. All right. So with that, getting a pop-up, let us jump into kind of some background of what we're actually going to be looking at. So our observability pipeline here is composed of 5 main components. Some of them are more obvious than others, but we'll start at the ground level. So of course, Presto is one of those components. Without Presto, the rest of the pipeline wouldn't really make a lot of sense. So, obviously that's our main piece. And this workshop and, intro slides does kind of assume some base level of knowledge about what Presto is and what it's for. But essentially, we're going to stand up a simple cluster. Presto will be obviously what we are intending to monitor. So we'll monitor the query state, resource group, constraints, memory, and general JVM health, things like that. The second piece, this piece is a little more on the abstract side, but it's called a JMX exporter. So this is an application that runs inside every Presto application node. So we'll have 3 nodes total. And it is what exposes certain metrics that Presto is creating in order that, we can scrape them and make any logical sense of what's happening and actually populate our dashboard with it. There's also Prometheus. So Prometheus is a time series database. And what it's going to do is essentially pull snapshots of our metrics that we're collecting every 10 seconds, label them, store them. And it also will do some rule evaluation based on some rules that we have defined. Then there are two pieces that connect to Prometheus directly. The first is Grafana, which is our actual dashboard tool. And obviously, as dashboards do, all that's doing is making our metrics a lot, more visually appealing and easier to ingest. Then also connected directly to Prometheus is the Alertmanager. So, as mentioned, Prometheus is going to be evaluating some rules for us as it's pulling this data. And these rules are things that we essentially have determined, like, this is important. If this happens, we want an alert about it. Now, Prometheus can tell us if that is active, if an alert is active, but it doesn't do the alerting for us. What we actually need for that piece is an alert manager that will actually route the alerts to whatever system that we choose to route them to, which in this case will be Slack. So now the next 4 slides-ish, 5, it'll just essentially be 1 slide per thing, per bullet point that I just mentioned. So a little more in-depth info about what each of these pieces does. So as mentioned, the Presto portion of this, it's a little more self-explanatory than the others. In Presto, the storage is completely separated from the compute. So Presto is just the compute. And this is what allows it to work on, really a ton of data relatively quickly. In our example here, we'll have 1 coordinator node and 2 worker nodes. So we'll get into what each of those does in a bit. But essentially, a client will submit SQL to the coordinator. The client in this case will be us using the Presto CLI. And then once the coordinator receives that query, it parses the query, in order to figure out what is being asked, plans it, applies resource group admission and queuing rules according to what we have defined, us as the Presto administrators have defined are important. And then it schedules the work. And the work itself is scheduled on the worker nodes. Workers can execute their tasks in parallel. Basically, what they'll do is workers are going to be the ones that are directly accessing the underlying data. And a single query can be split across multiple workers, depending on how much data is needing to be analyzed, or multiple different requests can be run each on different workers. It's up to the coordinator has an intelligent way of figuring out the best way to plan that kind of thing. Then ultimately, once the workers are finished with their particular tasks or subtasks, the coordinator is what does the final aggregation. And it's also the coordinator that keeps track of really all the higher level cluster state items, like the number of queries in the queue, the number that are running, the number that have failed, that type of thing. So in our case, both our coordinator and our 2 worker nodes, in addition to running their usual Presto application code, will also run a Java agent. This is the JMX exporter that I previously mentioned. And that agent is what's going to publish various metrics that we've deemed important as the Presto administrators to the port 8081 metrics endpoint that we'll get more into. If any of this doesn't make sense yet, no worries. I'm using a lot of terms that I haven't defined yet, but we will slowly kind of, spiral into an understanding of what all of these things do. There's a lot of pieces and a lot of configuration. that we're doing as the Presto administrators in this case. So there's just a lot of background knowledge. All right. The next piece that we will discuss by itself is Prometheus. As I mentioned, Prometheus is, I don't think I mentioned this actually, it's an fully open source software itself. And it is specifically in our case, a monitoring and alerting toolkit, but it's really just a time series database with, specific rules that it runs by. Prometheus uses a pull model to request metrics from whatever database it's requesting metrics from. In our case, this is, I guess I shouldn't say database, whatever system it's requesting metrics from, in our case, Presto, of course. And once it pulls, a snapshot, it stores it in its internal database. It has a special language, as every database does, called PromQL. And as any query language does, it just allows you to query whatever samples are stored in Prometheus, whether that's about the current state, trends over time, recent events, etc. And you also will define your alerting rules in PromQL as well. And we'll see some PromQL in our hands-on portion. So in our particular stack, Prometheus is going to take, we'll say, scrape data every 10 seconds from the metrics endpoint. Also, you could consider that instead of scraping every 10 seconds, like taking a snapshot every 10 seconds of the current state. And then it will also label, it does a little extra stuff as well. Whatever it scrapes, it will also label with, whether it's scraping some metric from the coordinator or the worker, things like that. We'll get more in depth in that in a bit. And then Prometheus, in our case, again, this is also configurable, but we've selected every 5 seconds. We want Prometheus to evaluate the alert rules that we've defined against this data that it's stored thus far. So, you can change this 10-second, 5-second setup, and we'll see where to do that. I think I've already kind of covered that little blurb at the bottom, but essentially the metrics that are posted to port 8081 on our local host are the snapshot, and then the Prometheus UI, which we'll also check out. That will be on port 9090 of our local host, and that's essentially what's making everything available for query. All right, on to Grafana. Grafana is also an open source software, and it is a dashboarding tool. So Grafana can connect to, a myriad of databases. Prometheus is, of course, one of them. Lucky us, because otherwise this workshop wouldn't work. But others, it can connect to many others as well. MySQL, for example, is an obvious one. And, it's just going to make it so it's nicer to view the data and easier to consume it. It supports, fully customizable charts, maps, tables, lists, things like this that, are all defined in a simple JSON config file, which we will see. And of course, dashboards are there just to help us understand what's happening with our cluster. That's the whole point of observability, right? So, we can see things like what is happening at this very moment, how many queries are running, how many are queued, are the workers healthy, things like that. We can see who is affected by certain outages. If you have resource group specific views, you can see if, one particular group is hogging all the resources, things like that, so that you can take action on that ideally. And also you can view trends of, how things have happened over time. So I kind of called this out earlier as well, but, in our session for today, that's only 90 minutes, we'll really focus on just a few of the panels that you'll see in the dashboard. Query state, query activity by user, top resource groups, the ones that are kind of more towards the top. But It's a very sophisticated dashboard, really. So you should check out, kind of as an exercise to the reader or the participant for later, play around with the other ones too. Like this, you can definitely learn a lot just by tweaking things in all the various config files that we'll see, breaking stuff, seeing, what's been broken and how you can fix it. Uh, it covers a lot more than we'll be able to today. Another piece, of course, as mentioned, is the Alertmanager. So in our case, an alert manager is kind of a vague term, but in our case, when we say alert manager, we're specifically referring to a separate service that exists in the Prometheus ecosystem. It's not Prometheus code, but in our case, Prometheus is the author of the container image that we're using for this service. So you could probably plug and play this with some other things. But yes, I'm specifically here talking about the Prometheus Alert Manager itself. So as I mentioned, Prometheus is what's actually evaluating the rules. We're defining our alert rules in Prometheus, in PromQL specifically, and Prometheus is evaluating them. However, all Prometheus can tell us is whether a particular rule that we've defined is in one of the following states, whether it's inactive, which obviously is a little self-explanatory, means nothing is happening. Pending means the rule is being evaluated as true currently, but it has not been true long enough to be considered a problem. Firing is, okay, yes, this is now a problem, and it's been a problem for some predetermined amount of time, and resolved, which is, again, self-explanatory. So Prometheus can tell you that, but it can't actually send the alerts themselves. So that's all the alert manager is really doing. It's getting the information from Prometheus that there is an alert that needs to be alerted on, and it's doing the work to send that alert through whatever system that we want to send it through, which in our case, again, is Slack. So here's an example of a rule we will directly be messing with in the workshop, the Presto queue backlog alert. So we'll see that we will have a rule defined in Prometheus where if the total number of queued queries is greater than 20, then we want to put that, if true, start evaluating for the next 5 minutes. If the alert is true for 5 minutes, we go from pending to firing for that alert. So we'll have some long running queries that are running for over 5 minutes that will force this condition to be true, at which point we'll see the alert manager take over and route a notification to Slack. All right, last 2 slides here, kind of the meatiest bits, I guess. And because they're more of an abstract concept, I feel like up until now, the pieces that we've covered are, somewhat self-explanatory. If we don't understand exactly how they work, we at least understand what it is. But there is one remaining piece that I want to cover a little more in depth, and that's that concept of the JMX exporter and why we need it, because it's not exactly a standalone piece like the other pieces are. So, as you may know, Presto is a Java application, at least, for now. And the versions we're using, the coordinator and the workers are both going to be Java, all going to be Java applications. We do have now Presto C++, which rewrites the workers in C++, but we will be using Java for our purposes. And as a Java application, every Java application that runs essentially has a built-in management and monitoring, mechanism essentially called Java Management Extension, or JMX. And that runs inside the JVM. So every, JVM has a JMX, and that JMX is exposing certain metrics. I'll call them metrics. They're not exactly metrics. They're more like Java objects called MBeans. An MBean is short for managed bean, I think. Yes, managed bean. So I might call them interchangeably MBeans or metrics. It gets a little, again, like I said, kind of abstract at this point. But as mentioned, MBean is kind of like a Java object that is exposing live attributes about what some application is doing. So, for example, in Presto, the Presto developers decide which, essentially what metrics might be important to expose, and they write the code in order to expose those metrics so that the JMX, Java Management Extension, can store them and read them. So in Presto, one of those MBean exposers, I guess, is the Query Manager class on the coordinator. So what that class as written is going to do is expose the current counts of running queries and queued queries, things like that. In addition, so Presto does, expose several of these MBeans, but also every JVM also has its own set of MBeans that it exposes. This is just standard across every Java application, but it will create, MBeans for things like heap memory usage, garbage collection, and those types of things. So that's great that we're collecting all of these attributes and their values, but the problem is Prometheus, and not just Prometheus, but like any, system that's wanting access to these metrics doesn't speak the language of the JMX, actual MBean itself. Prometheus, for example, specifically wants plain text, camel case, kind of Python-esque formatting that it scrapes from an HTTP endpoint, as we mentioned. So we really need to translate the MBeans in their Java format, essentially, into something Prometheus can read. And this is where the JMX exporter comes in. The JMX exporter is also a Java application. It's called a Java agent, and it will run inside the same JVM as our Presto nodes, each one. So we'll have 3 separate running instances of it. And the JMX exporter is what can read the MBeans directly, but it also translates the MBeans into Prometheus language, essentially. So we'll point this out, the specifics on this, as we're going through the workshop itself. But essentially what's happening is the agent is going to be injected, in a way, embedded into each running Presto node at runtime. And it's going to also include, when it does so, a set of rules that are essentially just regex rules that will match any number of MBeans if the regex matches, and translate them into a Prometheus alternative name. So there's an example here. Say a user submits a query, a user named Bob. Presto will determine that, based on the rules that the Presto administrators have defined, that the user Bob is a member of the data engineering team, and everything is part of the global scope. So once it does that, the query is essentially assigned this MBean in Presto, and we'll see the long form of this, but essentially you can consider that MBean to have a name that's something like, data engineering.bob running queries equals, it will have some value like equals 2, however many queries Bob is running concurrently. Presto exposes that information at the time it's happening. So this is all, happening in real time. Oh, excuse me. And then the exporter rule in our exporter rule YAML file, configuration file that we're sending in is going to capture that name and translate it according to our translation rules. So when it does so, it's going to capture things like not just the fact that, Bob is running 2 queries, but that Bob is a member of the data engineering team, Bob is the user, etc. And as well as some kind of more what can be considered metadata about this rule, such as the fact that it's the coordinator that is telling us this. The coordinator's in charge of query scheduling, so it's the one that's going to be exposing the running queries MBean, for example. So that is the JMX exporter, and in fact, pretty much concludes the slide portion of this. Yes, the next slide we have here is just an overview of some of the commands that we'll be running. But this is a good stopping point, I think, for questions. So let me stop sharing first. Oh, I guess I didn't want to stop sharing. I just wanted to stop my PowerPoint. Reshare. But yeah, I'll pause for questions here. I know it's kind of difficult since Saurabh, you kind of have to translate the questions for me at the moment. But if we have any questions coming in thus far, I will pause here to take them.
Sure, I'll keep in mind.
Excellent. One question I have for the audience, actually, before we get started, is are you familiar with Docker Compose? And yes, let me grab the GitHub repo link, Saurabh, while we're getting this going. Yeah, we can go ahead and share the link to the repo. So again, you don't have to follow along live if you don't want to. I know that can kind of sometimes be a lot to do. I definitely recommend, going through these steps after the fact if you're not going to follow along. But excuse me, I will try to, take it step by step. We'll kind of go through all the pieces. As mentioned, we're using Docker Compose, which for those that aren't familiar, it has its pros and cons. It's mostly a pro, I think. It makes it very easy to set up a pretty complex pipeline in one go with like just a single command. The only downside is sometimes Docker Compose, since it is so easy to use, it kind of can obscure some of what's happening under the hood. So I try to be really thorough, kind of going through the Docker Compose file and showing how all those pieces connect. But again, you can also, try it on your own time and like break stuff so that we can, so you can see how things are truly working. All right, okay, I do see we have some audience questions. So first question is, so without JMX, we won't be able to monitor. So I guess one return question I'd have is, what exactly do you mean by JMX? But truly the answer is yes, no matter what you mean. At least in this case, we have a specific, let me back up a little. There's the concept of JMX and then there's the concept of the JMX exporter. We need both. JMX is, you get it by default, so you kind of have to have it. The exporter, however, is also necessary. So if you don't include some exporter for the metrics, you can't connect to Prometheus and therefore you can't do, this particular workshop. Now, that's not to say, and this kind of hits my limit of what I know about Presto observability, as that's a mouthful, observability pipelines myself. There are potentially ways to do it where you wouldn't need a JMX exporter to translate these Java metrics into Prometheus. For example, if you're not using Prometheus, well, then you don't really have to translate in the same way, So certainly there's probably ways around this. For example, if you have a different setup that wouldn't allow you to use a JMX exporter Java agent in your setup, it's just, I'm not sure what that is, unfortunately. But it's something I should probably be familiar with. So yes, in our case, as mentioned, we'll be providing two things to every node, every Presto node, a jar file that includes the code for our Java agent. And as you can kind of see here, this is a file provided by Prometheus. So Prometheus developers wrote this Java agent specifically to do what we want it to do in our case. So they probably have other, agents for other languages and things like that. And then we also have to include a config file that defines our rules. But yeah, that was a bit long-winded, but essentially yes is the answer to that question. We do need a JMX and a JMX exporter for this workshop. So the second question is, how can I get a list of all available metrics and the parameters to use, like team, user, etc.? And I also kind of have follow-up questions to this question as far as what maybe you mean in this case. If you're wondering, like, for example, what are all the possible MBeans or metrics that Presto exposes that I could possibly scrape? Presto does have documentation for that, which I can point you to after the fact. I have too many windows open right now, but happy to track that down and find that. For this workshop, we are not selecting all of them. So we'll kind of see as we go through where we have this set of rules that we will provide to, this is the config file that we are providing for the JMX exporter agent. And essentially we're giving it a whitelist. So in our case, we want to scrape and to translate just those MBeans that have names that match these patterns. So we're not seeing all of them by all means. Like, there are many, many more than this that you can, again, like play around with, whitelist them in here if you want to play around with this particular workshop, and you'll be able to see those metrics then be scraped. Now, you also do have to provide, a translation pattern for each of these as well. So that does require a little bit of knowledge of regex. But yeah, suffice it to say, there's a lot more metrics than just those that we are collecting in our case. So it's worth a shot to kind of look into which specific ones are available, because the ones that we're going to use today might not be relevant to you. We're using some of the more, at least the easier to understand ones, in my opinion, things like the query managers, running queries and queued queries. That's a big one that we'll be focusing on. And then I did have another thing I think I wanted to mention here. Oh, okay. I guess also kind of tied into this question is also the concept of resource groups in Presto. So, it's a multi-layered, as mentioned, it's a very multi-layered workshop, because we're having, as administrators, to define a lot of the things that we want to track, but you might have a completely different way that you want to do it in practice. So we do have defined for only the coordinator needs this information, but we've defined our resource groups with certain names, and we can also set very specific limits and very specific configuration options for each of those. And then in addition to that, they are also nested. So in our case, we have, of course, up top is the global resource group. This is very common. But then we have sub-teams like data engineering. We also have data analysts. And I think there's more, yes, data science. So we have sub-teams, and then sub of that, nested within that, are specific users. So we have a Bob, we have a Sam. They are both data engineering people. So all of this is like completely configurable. You would configure this on your own for whatever, the resource groups of your cluster might be. They might not even be user-based like this one is. But in our case, thanks to these rules, gosh, it is hard to keep track of all of our configuration properties here. Thanks to these rules, we'll be capturing the way that they're shown in Presto, and then you can define labels to add based on these capturing groups. So if you're familiar with regex, you can see we have a capturing group here. We have another capturing group here. These will correspond to the labels that are given. So we're saying we want to call whatever is coming out of capturing group 1 the team, whatever's coming out of capturing group 2 the user. You can change these as desired, but the format that we're actually using here, let me get my slides and bring them back over here. What we're actually matching with that is this. So this will be capturing group 1, capturing group 2. So it's fully configurable, which is great, but it does make it kind of more complex, for at least for like an intro workshop to this type of content. Oh, does the complexity, so we do have another question, and feel free to ask follow-up questions, either here or, Adam in Slack, whatever you prefer. We do have a third question. What does the complexity of the rules affect Presto performance? And the answer is no, not meaningfully. So, I mean, of course, this file can get pretty complex, and especially if you're including many, many more than we are in this example. But it really shouldn't affect Presto performance. Presto's pretty good at resource siloing and things like that. So this is taking up a very minuscule, like a relatively very, very small amount of the energy that the JVM is running on as far as Presto goes. Presto will always prioritize completing the query over kind of like bonus stuff like this, for better or for worse. So you might see, again, if you go through the workshop there, you'll probably notice, at least I've noticed on my machine, when we're running a lot of queries at once, some of the pipeline, the observability pipeline elements can kind of start dragging, or they're not updating maybe as frequently as they were when a smaller workload was running. But you will always see in the Presto UI that, in fact, the queries are completing successfully. So it's kind of just goes to show that, yeah, Presto will always prioritize getting the query done. And depending on the resources that your machine has for this workshop, or your overall system has in a real world scenario, you might get a little delayed on the updates, because it does have to pass through several gates, until it gets to the dashboard portion. You got to go through the JMX those metrics have to be posted to some endpoint. Prometheus has to scrape that endpoint. Grafana then has to get that information from Prometheus. So there's a lot of points in the chain where things might slow down a little. At least in a 90-minute workshop, that's very obvious. In a real world scenario, you're probably not worried about a delay of potentially, I mean, maybe you are, of 30 seconds or, a few minutes, but yeah. Sorry, I'm a long-winded question answerer. Okay, I think questions have slowed. So I was thinking we could get started kind of going through the workshop. Did anyone answer about their familiarity with Docker Compose? Just curious. No worries if not. I'll give like a shorter Docker Compose intro, but again, as always, if it's not enough, just let me know and we can chat on Slack or wherever. All right, so let's get going. So shared with you was this GitHub repo. So if you're going to be following along, you would have to git clone this repo because everything we need to complete the workshop is in this repo. How many times can I say repo? And in addition, there's a lot of good, after the fact, definitely read through this README. Lots of good info in here about all the different pieces and how they're fitting together and what all the different config files are and all that good stuff. But once you've cloned this repo, change into the directory that you cloned it into. And we're just going to run a docker compose up command. -d just means don't output all the logs. We just, want it to be kind of a more silent operation in the background. And press enter. You'll see we have a lot of pieces that are present. And by pieces, I guess I mean services that are present in this pipeline. And when you do this, I've already done this naturally, just to make sure everything was working. But if you're doing this for the first time, yours will probably take quite a bit longer because you're going to have to pull all of the images that we need in order to get all these pieces together. So usually while that happens, I just give the overview of our Docker Compose file so we can kind of understand a little more about what's going on there. Probably the Presto image itself is going to be the largest of any of these. So yeah, not uncommon for that one to take a bit. And then even once they are, we're getting the output that these containers have been created, I like to give it another minute or two anyway before the container application code is actually up and running. So we will, while we do that, just quickly look at the Docker Compose file and see what's going on here. So the services, each service here is going to look pretty familiar. It's going to be all of the components that we mentioned in the slides. We have our Presto portion, Prometheus, Grafana, Alertmanager, and the JMX Java agent, exporter Java agent that we mentioned as well, which it goes inside each Presto node. So just for an example, here's our coordinator. Coordinator, we're specifying the Presto image we want to use, giving it a name. And then we also do expose a few ports. And what this is doing is it's saying, okay, anything that's happening on port 8080 inside of our container, we want to be able to access that on our host machine's local host. And same with port 8081. Anything happening on port 8081, we want to be able to see that in our local machine at port 8081 as well. So 8080 will be our Presto UI. 8081 will be our metrics endpoint that Prometheus is scraping from. And then for all the volumes here, we what a volume is it's taking something at this local relative path, and it's putting it inside the container at this path within the container. So most of these paths are just the predefined paths in Presto that you have to put things like this, or the default for where those types of things go. We've kind of gone over, each one here has a comment kind of explaining what its purpose is. We've gone over these two. It's the rules for the JMX exporter translation, as well as the actual Java agent that will be inserted before runtime. But some of these other things, if you're familiar with Presto, they will look familiar to you. There are various config files, like how we want the JVM to be configured, how all the the properties for this particular Presto node, how we want that to be configured, as well as how we're connecting to the Prometheus service, and how we're defining our resource groups, things like that. So you can find any of these files at this path relative to the Docker Compose file. So for example, we have Presto coordinator, etc., resource groups. We saw this one. The config.properties is just defining things, properties for this specific Presto node, like the fact that we want this node to be a coordinator and do its conversating over port 8080, things like that. The other two Presto services look much the same. They don't require quite as much configuration because they don't need knowledge of the resource groups. That is specifically a coordinator duty to keep track of resource groups. But we do have still the JVM config for that particular application that's going to be running, properties for this node, etc. Worker 2 looks almost exactly like Worker 1 with the different name. Oops. And then the rest of the services as well, kind of speak for themselves now that we understand how these things are working. So each one will have different ports. These are usually just the default ports. They can be configured as well, of course, but we'll be accessing all of these on our local host so that we can see how everything is working. And yes, each service has usually multiple configuration files that we are passing in to the container when it's being started up so that the service knows how to, configure itself, essentially. So usually by this time, I think we're safe to assume everything is up and running. And what we can do to assure that is open a bunch of tabs on our local machine. So we have that one. Let's try all these. I'm just going to refresh to make sure they're up and active. So this is the Presto UI, always accessible, at least by default, on port 8080. And all of these will be localhost addresses since we are mapping everything to our host machine. So great, we have 2 active workers like we're supposed to. That means all of our Presto nodes have started successfully. We also have this relatively uninteresting, but important nonetheless, endpoint. And this is the port 8081 metrics endpoint that we've been mentioning. This is the endpoint that Prometheus will scrape. So this is where the JMX exporter it's already done its translating job, and it is exposing all the metrics and their values at this given point in time. So when I hit refresh, that was essentially asking it to, refresh the snapshot for this exact moment. And whatever this number is, for example, is what the value of that attribute is at this moment. So if we did it again, it would change again. But this will not update dynamically. Like you have to request it to be, to get a snapshot, essentially, just like Prometheus does every 10 seconds. Here is our Prometheus UI. As you can see here, we have a few different tabs. So it's, a fairly, you can go fairly in depth with this. This query tab is where you can enter PromQL expressions. So we already saw on the Presto UI that our workers are up, but you can also use Prometheus to see the same. And what it's going to show us, since this is one of the metrics that we've chosen to expose, we will see that the value is 1, 1 meaning true. In this case, like true, it's a true Boolean. So if it weren't up, the value would be 0. So you can also see this information in the target health panel. So we are targeting all 3 of these Presto nodes to be, and the endpoint is the same for each one. It's just the 8081 metrics endpoint on all of them, but all 3 are healthy. And there's also here an alerts tab at the top. And these will be, this handily tells you also where these alerts are defined. So, from within the container, they exist at this path. But as we saw in our Docker Compose file, this is where they are locally. So you can kind of go in and see like, okay, these are all of our rules and how they're defined. We'll dig a little more into that in a bit. We also want a tab for Grafana. So Grafana does require a password and a username, which was also defined in the Docker Compose. If you forget, it's just admin and admin. So that's pretty easy. I know I don't want to save this. And I don't want to update my password. But yeah, here's the really cool Grafana dashboard. I'm going to zoom in a little. Tons of panels, as mentioned. A lot of them don't have data right now. This is to be expected because a lot of MBeans are exposed dynamically. So, we do not have information, for example, about how many queued queries are in the queue right now because this MBean has, up until now, not even been exposed anywhere in the application code. So some of these will show no data, others will have data. So this CPU usage, for example, this is a built-in JVM MBean, not a Presto specific MBean, but just kind of an application specific MBean. So it will show us, CPU usage and memory usage for each particular node. And many of these will not have any data yet either. But yeah, we'll be focusing mostly on the top portion of this dashboard today. Okay, that's really all the tabs you need open. And even then, need is a strong word. But let's actually start doing some things. Okay, so let's run another Prometheus query. We've not run any Presto queries, obviously. Our cluster is just sitting idle. However, if we run this Prometheus query, we are basically saying, how many running queries are present right now? The answer is, of course, 0, as to be expected, because we have not run any queries yet. Great. Everything is looking good with that. And similarly, you can do the same. It's a little clunkier. You kind of have to search for the exact, metric name that you're looking for. But you'll see, same deal here. We have 0 running queries right now, as to be expected. But let's actually run a query so that things start getting a little more interesting. So to do so, we'll go ahead. I'm just going to separate this into a separate terminal tab, but you can do it in the same tab if you'd like. We're going to run a docker exec command on the Presto coordinator that essentially is going to start the Presto CLI as the user Bob. So when we run this, what happens is, we're going into the Presto coordinator and accessing the CLI of the Presto coordinator so that we can make queries. And we're wanting to run kind of a longer query so that while it's happening, we can actually see things changing in our various pipeline components. So if the query happens too fast, it can be a little less than exciting, because by the time all the information propagates to the final pieces, your query is over. So you missed all the action. But let's run a long running query. And you can find such a query in this script. So we'll run this script as a script later as well. But for now, if you want to run this query, this will be the query that we're running. You can just copy and paste it, into the Presto UI. And it should start running. So yes, Presto got it. It's working on it. And now we can essentially go through all of our pieces and see what's updating. So as expected, we now have one running query shown in the Presto UI, and it also appears here in the query list. We can also refresh this metrics endpoint. It does take a little bit to refresh. And I might have done it a little too soon. So let me just wait 5 more seconds and refresh again. It's not quite as real time as you would hope it would be, but eventually, it will show us what we want to be shown. And it's not for some reason. Okay. I guess the query finished too fast. Wow, my machine's really doing a great job today. Well, in order to fix that, what you can do to make it take a little bit longer is update. This takes quite a bit to scroll all the way over. But update this particular number, it starts at 50. Try 100. That'll slow it down a little bit so that hopefully we can see this time everything performing. All right, so we've jumped back up to one running query in the Presto UI as expected. Let me give it 5 more seconds. Now let's try refreshing this. So yeah, there's a bit of an art to it to find a query that's going to run long enough that you can actually see all of these pieces occurring without, there we go, without it taking too long, But here we are, as promised. We have one running query. We can do the same, query Prometheus. Okay, great. There we go. And we will get the same number of running queries. It's 1. Perfect, just as we expected. And then similarly on the Grafana dashboard, we're going to see, I think the query might have already finished running, but we can see this data start really populating. So we've already registered the second query that we ran as completed. So apparently the query has completed by now, but we can see this, queries per second trend line is starting to show us bursts here. We have similarly, some information about the current query state here, although we are back down at 0. So, easy enough. And then query failure rate has also started to populate. It's also at 0 because no queries have failed, which is great. And we will also see that in the top users and the top resource groups, we now have data here as well. Now, this is running queries and queued queries. So of course the number is 0. All of our queries have completed right now. But it's smart enough to know that Bob has run a query before, so it's going to start populating the data for Bob. And similarly here, only the data engineering resource group has submitted any queries thus far. So those are the only 2 groups that will show up at this particular time because, it hasn't dynamically discovered the rest of the groups yet. But we'll see that change in just a bit. And you'll definitely see it. Well, maybe you won't. My local machine is a little bit constrained. So, you'll see these numbers start to exceed 80% often on mine, which, is normal just based on how much memory my Docker containers have access to. But yeah, don't be alarmed if that turns red. But, in a production environment, you can see how this would be very helpful to be able to view in real time. But again, I will stress, so I believe the default here, you can set the refresh defaults as well as the, for historical trend-based panels, the history that you're viewing. I believe the default refresh might be 5 seconds in Grafana, but I set it to 10 because there's really no, Prometheus only scrapes every 10 seconds anyway. So we don't need Grafana doing twice the work to refresh if we know there won't be new data available by then. But of course, it won't be the exact 10. It's not going to be an exact 10, like every 10 seconds it will update because there might be a lag on Prometheus or in any of the other components. But just for some clarity there. And then you also notice the way this panel is defined, the completed queries, I believe some of the other ones failed as well, are only tracking those in the last 5 minutes. So the first query that I ran was over 5 minutes ago, apparently, because now this count has dropped from 2 to 1. So we only have 1 completed query in the last 5 minutes. But let's make it a little more interesting here. So you can always submit queries via the Presto CLI. You can have, multiple terminals open to submit multiple at a time. But for efficiency's sake, we also do have this script in the scripts folder here called flood queue. And it's fairly straightforward. It's basically doing the same thing, just programmatically. So it's going to, start a Presto CLI, but instead of a terminal, it's just going to do it programmatically. And we're going to submit 31 queries, each on a different user. Well, I mean, not each on a different user, but for Bob, we're going to submit 11 queries as Bob. We're going to submit 9 queries as Sam and 11 queries as Noah. And the query is the same query for everyone. It's just going to be this relatively long-running query so that we can see the numbers in the dashboard change and, what happens when we're doing. Let me check my time just to make sure. Okay, I think I'm good. So let's go ahead and run this script. And you'll get a little feedback in the console that the queries are being submitted. Now, there is always a chance that some of these queries might fail for various reasons. Perhaps they shouldn't, but they might, you never know. So just in case they do, this script also does start a query log file for every query that runs, so that if there is a problem, you can inspect the logs and see maybe what was going on. As you can see, I've run this a handful of times in the last few days. But yes, okay, now that those are submitted, let us go through the flow again. So as we can see, we've got a lot more numbers going on here than we did before. We have 10 running queries and 21 queued queries. And that is what we are expecting to see. So why, you might be wondering, why are 10 running and 21 queued? This comes back to our resource group definitions that we gave to the Presto coordinator. So the Presto coordinator is managing who's being scheduled. And as you can see here, Bob we submitted 11 queries as Bob, but Bob has a running query concurrency limit of 4. So he's only going to run 4 queries. We submitted 9 as Sam. Sam has a max running query number of 2. And we submitted 11 as Noah. And Noah also only has 4 available that he can run at any given time. So this is why we are seeing the number of running queries as 10. The rest of those queries are going in the queue. And will be dealt with as soon as the running queries, as soon as all the rules come together, essentially, that allow for more queries for different users to, occur. And you can set up, the rules by which the coordinator selects queries to be run. You can prioritize certain groups. And this, I think it's just, the default. So just whatever is being round robin first is being selected. But yes, this is the reason that we're seeing this number of queries. Oops, I lost my mouse. And I'll also take this moment to say, if you're not familiar with resource groups, this is one exercise that you could do perhaps on your own time. But as you can see, there's a max queued amount, and there's also, hard concurrency limit for concurrent running queries. So say you submit, instead of just 11 queries for Noah, say we submitted like 30. What would happen, assuming in this case, no other queries are running, 4 would start running right away, no problem. 20 of those would be queued. So that would be a total of 24 queries that are either running or queued. Any other additional queries, so 6 remaining queries, if we submitted 30, will be rejected. And you'll see feedback on that happening when I believe you will only see that on the Presto UI, because I don't think we're exposing that metric in the rest of the pipeline, although I could be mistaken there. But yes, those will be rejected, and they would have to be rerun by Noah at some later time. And you would get feedback on that as to why that is happening from Presto, of course. So let's again see how we're tracing these through. As mentioned, these are the same queries, so they take a little bit longer to run than a simpler query would. But now when we refresh our metrics endpoint, we should have a lot more running queries. And we indeed do. Great. Same with this, except sometimes it doesn't like to behave, apparently. Okay, well, that's fun. Let's see what might be going on there. All right, so this will happen as well. So if this happens to you, don't be alarmed. So I'm in the status target health page panel of Prometheus. And this is really, in my case, just a Docker constraint that's manifesting as, it looks like a pretty serious error, but it's actually a good representation of how Presto and Prometheus are speaking to each other. So it's kind of a good opportunity to mention this. But you'll see in the Presto UI that, and this kind of ties back to one of the questions that I addressed before we got into the workshop portion as well. We have, according to the Presto cluster, both the workers are active, they're doing their work. Clearly, these are all dynamically updating. And the coordinator is also naturally alive because we can view the UI. You could also check similarly that your Docker containers are up and running still too. So there's many ways to do that. But as you can see, Prometheus is seeming to indicate that there's actually an issue here. And there is an issue, And it is kind of explaining, it's not necessarily saying, hey, this worker is down, for example. But what it is saying is, I as Prometheus could not scrape this 8081 metrics endpoint for some reason, which is fair. And the reason that's happening in my case, well, this is a guess, but I'm fairly confident that this is why. Again, I don't have a ton of Docker memory available. So what's happening is, either the network is getting overloaded, my Docker network is getting overloaded, trying to refresh, or, things are temporarily have paused on the collection front in order to prioritize the queries running. So that will always be the case. If it has to drop something, it's going to drop the less important thing, which is the observability, even though it looks kind of concerning and scary. What's really happening here is not quite that the container is down or the node is down, but just that for some reason it cannot scrape the metrics endpoint. So you might see this in your instance as well. Hopefully you wouldn't, based on what all your host machine has available to it. I'm due for a device refresh, so mine's a little finicky. But over time as well, and you never know how long it might take for this to happen, but once the pressure on the cluster is reduced, Prometheus will eventually again be able to scrape the metrics endpoint, and it will, back down on its alert firing. This is also a good time to kind of show a little bit more about the alerts. Oh my gosh, I only have 10 minutes left. Okay, let me go through this quickly, and then we'll quickly go through the Slack portion and conclude. Although I don't have anything immediately after this, so I can, potentially stay on for questions depending on how other people are time-wise. Okay, so as far as the alerts panel of Prometheus, as mentioned, this is just showing you a nice UI version of all of the rules that we've defined in our alert rules YAML file. So let's go to that file locally. And we can see here that these rules have been, in our case, predefined, but again, we're the administrators. So we can edit these alerts or add more or remove some as we wish. But one of these alerts, especially the Presto worker down alert that we've been seeing, is currently firing. So how does that work? Well, this is just the alert name, easy enough. This is the PromQL expression that's being evaluated. So whenever this expression is evaluating to true, the alert is considered pending, and it will show up in here as pending. This is not the same alert, but you'll see this yellow pending thing. If that state happens for 1 minute, over 1 minute, then it moves, the alert moves from pending to firing. So as we can see, this is still firing. It's been over a minute now since the Prometheus endpoint has been able to reach that metrics endpoint for the worker. So we move it into the firing condition. The labels for this one, we're using a severity of critical. We'll see that in action in our actual Slack notification system, but for now you can also see the label applied here as well in the Prometheus UI. And then of course a description and a summary of what this alert actually does. So you can play around with this. You can set this to a larger time. If you're not super concerned that a node is down or one particular node is down, it's up to you to decide what the concerning amount of time for a node to be down is for your particular case. I will say this, if you change any of these config files as you're messing around with it, you do have to restart the service for which whatever config file you've changed needs to be refreshed. So if you were to change one of these to a different length of time, you would restart the Prometheus service. And I will show you how to do that here, in fact, because I want to get through the Slack portion of this really quickly as well. So as mentioned, we have our alert manager set up. It's currently not doing anything. And we'll see why in a bit. So our alerts are firing. They're just, nothing is becoming of them because, we haven't set it up to do so. So what we want to do is set up in Slack a webhook that we can connect our alert manager to in order to receive these alerts. So there's instructions here in the README. This is the repo README for exactly how to set this up. But just as a short, since we're running out of time here, a short summary is you create an app. So I use my personal Slack workspace. I have, I'm a member of several enterprise workspaces as well. Probably don't want to use those for this demo. So I just created like a free trial demo workspace in my personal Slack. And as a result, I was able to, I'm able to like test these things and make sure that everything is working. So I recommend you do the same, but the instructions are here. They're as simple as they look. It's really just this. You follow a few prompts in the Slack UI, and you will eventually, to create an app, you can name it whatever you want, and you'll eventually come to, when you click this incoming webhooks portion here on the side, something that looks like this. So this is my webhook that I previously created. It allows you to configure this, but you can configure the channel that you want it to be active for, and it will provide you a URL. So once you have this, you copy the webhook URL, you come back in here to the Alert Manager configuration. I think, mine is still active, so I won't have to restart. What you would do, here you'll see a placeholder. You just go ahead and paste your URL there. And then also make sure if you didn't use a channel called Incident Alert, which is the placeholder, you just make sure that you're putting in your channel that you've specified for the webhook to work. And then you would run, do it in this, that's ugly. I don't know if you need the compose, but I'll put it in anyway. Docker compose restart alert manager. So this will just restart everything with the new configuration file that is now edited to include your webhook URL and your channel. Since mine was already active, I don't have to do the restart. The restart is fast for this service. It's a very simple service to set up, but nonetheless, I don't need to. So I'll just show you what it looks like when you're actually going through it. So this is an example of what you will see as a result of the Alert Manager rules. It's pretty sophisticated for the, this is all that's set up here. It's this, less than 10 or less than 20 lines of YAML code. And you get, a color related to the status of the alert, whether it's resolved, if it's just a warning, if it's critical, you get this red color, warnings are yellow. All of this is defined, in this short little config amount. And also I will just point out here, similarly here, you see that we've selected various labels, severity high, severity warning in our Presto or in our Prometheus alert rules. Those are just simply mapped here to their colors with if-else statements. fairly simple. But yeah, basically anytime an alert is firing, so not pending, but firing, we will get a message in our Slack channel telling us, what's going on here, so you can act on it right away. And we've also selected in this Alertmanager config file to also send an alert when whatever was previously firing has moved back into resolved status. So since that is true for us, we can see here that that is indeed working as intended. Before, Prometheus was evaluating the fact that one of my workers was down, or two of them were down, in fact, as you can see, since you get the double message and the information about which instance it is here. Two were down. Luckily, the Presto worker 2 has now come back online. The pressure on my cluster must have reduced to a degree where, now the metrics endpoint is able to be scraped again for worker 2. So we got the notification that indeed the worker is back online. So I do feel like I was rushing through that last part a little bit. I wasn't expecting to to be rushed towards the end. I thought I had plenty of time, but that's the fun of a new workshop. You never really know how much time it's going to take. But yeah, check it out, play around with this. It gets a lot more interesting when you're submitting these multiple queries. As we can see, the trend lines are a lot more interesting with the queued and the running being different. We also have, well, I wish I would have shown this while the queries were actually running, but these will dynamically, increase as the number of queued and running queries are changing. Same with for each user. You also get information about the query latency. So, for example, if your P99 latency is really high, but your median is fairly low, this is going to be telling you certain things about your cluster. Same with all of these later Grafana panels. I don't know. I'd highly recommend checking them out, figuring out what they do, figuring out some queries you can run to try to mess with them and see how things change, update how you're displaying your data, things like that. It's highly configurable, all of this. So I do recommend that you give it a shot. Okay. I will take some questions. I know we're right up at the end of the times. So it's up to you, Saurabh, but I'm also available in Slack, so don't hesitate to reach out if you need to. You're lagging a tiny bit. Let me also put this up here.
Great, great. So, yeah, thank you so much, Kiersten. I think it was wonderful. And I think we have dropped all the links in the chat box of this video. So, developers, if you want to uh, try out the complete workshop, the GitHub repo has been, the link of GitHub repo is in the chat box. Please check out, right? And Slack channel link we have dropped as well, right? So thank you so much, Kirsten. I think it was wonderful. It was a great workshop.
Great.
Personally, it was starting from the JMX metrics and everything. It was great. And guys, if you have any questions, please uh, don't hesitate to join the Slack channel and drop your questions, right? And Kirsten will be there uh, to answer any doubts if you have, right? Uh,
Yes.
thank you so much, Kirsten. I think we don't have any questions in the chat box, but yeah, if we get any
All
questions,
right.
we'll take it from the Slack itself, right?
Perfect. I'll
Thank you
keep
so
my
much
eye
for
out.
thank, yeah, yeah. Thank thank you so much once again. And developers, if you want to join our community sync call on 26th August at 9 p.m., we have our sync call. So please join the sync call with one of our committers. So if you want to get updated with the latest work that we are doing, please join this sync call, right? I'll drop the link as well. Uh, yes, I have dropped it. So please join the sync call as well. Okay. Thank you. Thank you so much. Thank you so much, Kiersten, for your time today.
Thank,
Thank you.
thank you. Thanks, everyone. Talk to you soon.
Bye bye.